All right, so you've heard the buzz, right, about AI agents, these like autonomous systems that can go off and perform tasks for you. But where do you even begin to understand them? And why are there suddenly so many different ways to build them? It's a bit much, isn't it?
Yeah, you're definitely not alone if you're feeling that way. I mean, it is a lot to take in. I think that's exactly why we're doing this deep dive, to try to demystify
Mm.
AI agents for anyone who's kind of new to the whole concept. And also, we'll take a little tour through some of the big frameworks that are out there, see what makes each one tick.
Cool. So when we talk about AI agents then, what's the core concept? I mean, the thing we really need to wrap our heads around.
It's really about autonomy. I mean,
Okay.
you can think of it as you've got this large language model, right, that's already pretty impressive at understanding and generating text. But now you give it the ability to use tools to actually do things in the world. It's not just passively responding. It's like setting a goal and letting the AI figure out how to achieve it.
Okay. So it's not just about giving an LLM a prompt and getting a response. It's more than that.
It's a huge shift. It's moving from a single interaction to this ongoing decision-making process. So with a static prompt, you ask, and the LLM just responds. It's limited by its training and whatever you put in that prompt. But an AI agent, it can decide on a whole sequence of actions. It can figure out which tools it needs, to reach a larger objective. So the LLM is like a reasoning engine. It's dynamically figuring out what to do and how to do it over multiple steps.
So it's like actively planning and then executing those plans, not just reacting to something.
Exactly.
That makes a lot of sense. So, okay, what are the essential parts, the building blocks of an AI agent? What do we need to be aware of?
So a typical AI agent architecture, it has a few key parts. The first one is, well, it's the language model itself, right? The LLM. That's the brain you were talking about before. It understands instructions, it reasons about the situation, and then it decides what to do next based on all that.
Okay, that makes sense. So then we have the tools. Is that next?
Right, the tools. And these are like functions or APIs that the agent can use to actually interact with the world. So, things like searching the web or accessing information in a database, maybe running some code. It could even be controlling physical devices in some cases.
So the tools are how it gets things done. It goes beyond just, generating text on a screen.
Exactly. It's the hands to act, if you will. Then you've got what we call the agent executor. So this component, this is what manages the whole back and forth between the LLM and the tools. So it takes the LLM's decision, about which tool to use, it executes that tool, and then it feeds the result, which we call the observation back to the LLM. And this whole cycle, this back and forth, this is the action observation loop.
Got it. So it's this cycle of doing something, seeing what happens, thinking about it, and then doing the next thing, like a kind of a guided trial and error, but driven by the LLM.
That's a great way to put it. And then finally, there's one more piece. It's often optional, but it's really useful, and that's memory. So this is like giving the agent the ability to remember information from previous steps or even, from a whole conversation. So it can actually build on what it's done before. And it can have a more coherent strategy for reaching its goal.
That's interesting. So it's not just stuck in the present moment. It has some context.
Right. It can learn and adapt over time.
Okay, so we've got the LLM, which is the brain. We've got the tools, which are the hands to act. And then the agent executor, which is the manager, making sure everything runs smoothly
Right.
with that action observation loop. And then sometimes we have the memory as well. That's a really helpful overview, I think.
Yeah.
So let's dive into some of the specific frameworks out there. You mentioned that there are quite a few. So where do we even begin with all these different AI agent building kits?
Yeah, there are quite a few popping up. Each one has kind of its own core ideas, its own strengths. Maybe let's start with the OpenAI Agents SDK.
Okay, so the folks behind some of the most powerful LLMs, they're offering tools to build agents too. Makes sense. What's their basic approach?
So their Agents SDK, it's a set of tools, mostly in Python. And it's all about giving developers pretty direct control. A lot of control, I would say. The idea here, and it actually grew out of their earlier Swarm projects, which is more experimental, but the idea is to provide this minimal layer of abstraction. So you're working pretty closely to the metal with the LLM, with the tools, and it's all within Python.
Okay, so it's pretty hands-on then.
Yeah, very hands-on. But it's also super flexible in terms of which LLM you can actually use. So as long as the LLM supports that chat completions format, which includes models from OpenAI, obviously, but also things like Anthropic's Claude model, Google's Gemini, and others that follow that standard. So you can plug and play a bit.
That's pretty cool. So you're not locked into just using OpenAI's models.
Exactly. You've got options.
Okay, so what are some of the things you can do with this SDK? What are the key features?
So a big part of it is the agent loop. This is what manages the entire life cycle of the agent's interactions. from start to finish. And it has built-in support for a bunch of different tools, like searching the web, looking through files, even doing things like speech-to-speech. It can chain different AI models together, too. They use their real-time API for that. It's pretty powerful.
I've heard about that real-time API. It's supposed to be really good for multimodal stuff. So what are the main advantages then of going with the OpenAI Agents SDK? Why would someone pick this one?
Well, it's lightweight. It's easy to learn, especially if you're already comfortable with Python. You can get a basic agent running really quickly, and just start experimenting. They've also got this really neat tracing dashboard, so you can see exactly what your agent's doing at each step, which is amazing for debugging. And of course, you get easy access to all the latest OpenAI models and their tools, which are constantly growing. Plus, like we talked about, you've got the flexibility to use LLMs from different providers, so you're not stuck in one ecosystem. And it's designed to play nicely with other Python code.
Okay, so lots of good reasons to consider it. What about the downsides? Anything to watch out for?
Well, even though you can choose different LLMs,
Mm,
if you're using their SDK and their tools, there is a chance of getting kind of locked in to their ecosystem.
yeah.
And depending on how you're using their services, there could be data privacy things to think about. Just something to be aware of.
Right. Okay, so that's the OpenAI Agents SDK. What's next on our tour of agent frameworks?
All right, let's look at Crew AI.
Crew AI. Okay.
So this one's also Python-based, but it's really all about multi-agent systems. So you're building and managing multiple AI agents that are working together
Mm-hmm.
to try to achieve some kind of complex goal.
Okay.
The core idea is that you create these role-based AI agents, and they collaborate in crews. So it's almost like having a team of humans,
Yeah.
but with different areas of expertise.
I like that analogy. So you're assigning specific jobs to different agents. That sounds really interesting for tackling, bigger problems, things that have lots of different aspects.
Yeah, exactly. And they've got these things called flows. That's for the more structured automation tasks,
Yeah.
where the sequence of actions is more predefined. But the really cool stuff is with the crews. This is where you set up the roles, you define the tasks and the overall objective, and then the agents themselves figure out how to collaborate and get it done. They have modular design. So you define your agents, you say what each one needs to be able to do, and then the framework handles all the coordination underneath.
That's impressive. So what kinds of features does it have to make this whole team-based AI thing work?
Well, the features are all about that collaboration aspect. So you have the crews themselves, which is these autonomous teams of agents. You have flows for when you need those more rigid workflows. You can define role-based agents, give them specific skills or goals. And then there are flexible tools. These can be custom functions you write or integrations with APIs. And there's a lot of emphasis on intelligent collaboration between agents.
So they're not just working in isolation, they're actually communicating and coordinating.
Yeah, they're designed to work together. And there's robust task management. So you can choose if tasks need to be done sequentially or in parallel. And you can even model different management styles, like having a lead agent that's kind of overseeing the whole crew. There's support for both short-term and long-term memory within a crew. And they have a wide range of LLM support, so you can use OpenAI's models, but also open source models through platforms like Llama and LM Studio. And then, of course, it integrates with a whole bunch of other systems, too.
That's a lot to unpack. So what are the big advantages of using Crew AI? Why would someone choose this framework over the others?
It's pretty intuitive to use, especially for Python devs. And its real strength is in the whole multi-agent collaboration. It's really good at that. It's really flexible. You can customize how you design your crews and your workflows. It's designed to perform well. They support lots of different language models. And they have this focus on production-ready applications. They have a GitHub integration, which is really helpful for team development.
Mhm.
Oh, and it's particularly well-suited for automating complex business processes. I've even seen them mention a visual interface option, which could make it more user-friendly for people who aren't hardcore coders.
A visual interface. That's interesting. So it could be for a wider audience then, not just developers.
Potentially, yeah. And it's got some advanced task scheduling features. You can
Yeah.
be really specific in how you design your agents. And because of the collaborative nature, you often get more accurate and robust results than with a single agent. It scales well, it's reliable, and they've put a lot of thought into security and cost efficiency. And you even get real-time analytics on how your crews are doing.
That sounds like a very powerful framework for anyone working with multiple agents. What about any potential drawbacks?
Sure, since it's so focused on multi-agent systems, it may not have as many built-in integrations for simpler tasks, things you could do with a single agent. And some of the more advanced enterprise features, those are part of their commercial offering. You do have to learn how to work with it, how to design those crew-based workflows effectively. And things can get tricky when you're dealing with really big, complex crews. Like planning and revising things on the fly isn't super straightforward.
Right. I can imagine that could get pretty complicated.
Yeah. And implementing complex logic in the workflows, that can be a bit cumbersome. And if you're just doing something really simple with a single agent, it might be overkill. It can be more resource intensive than you need. And while they do mention a visual interface, you still really need to know Python to use the core of the framework. And something to keep in mind is that agents within a crew, they don't automatically learn from each other and transfer that knowledge to other workflows. So there's no like built-in cross-training
Do
happening.
you kind of have to train each crew from scratch?
Yeah, in a way. And the pricing for the commercial tiers, that's something to be aware of. It might not be right for everyone. And it is open source. So that means the code is out there for anyone to see, which might be an issue for some people if they're working with, super secret algorithms. And I have seen some reports online of people running into rate limits with external tools after an agent has finished a task. So that's something to watch out for.
Okay, good to know. So a lot of power and flexibility, but some things to be aware of, especially around the complexity of the crews and the cost. So let's move on to our next framework. What's up next?
How about Pydantic AI?
Pydantic AI. Okay, so Pydantic is already pretty well known, right? At least in the Python world. It's all about data validation. So how does it work with AI agents?
So Pydantic AI is kind of a bridge
Hmm.
between developers and LLMs. It's really all about type safety and making sure you get structured outputs from your models. It's built on top of the core Pydantic library.
Hmm.
And it's designed to be model agnostic, so you can use it with all sorts of LLMs. And it's got a really flexible design. You can do dynamic prompts, reusable tools, modular architecture. They even have things built in for retrying failed operations and handling exceptions.
Yeah.
So it's very robust.
Sounds very Pythonic. So the main idea is to make sure all the data going into and out of the LLM, that it's clean, it's well-defined, and it follows the right structure.
Exactly. It's all about making sure you can trust the data and making sure that the LLM is actually giving you something you can use in your code. So some of the key things it does, it defines and validates data structures. It validates and parses the responses that come back from LLMs. It's got tools to build agents for specific tasks. And of course, it uses function calling and those structured outputs. So some common things people use it for: intent detection, searching knowledge bases, sentiment analysis, things like customer support agents, and even email assistants.
So it sounds especially good for applications where data integrity is super important. You know where you need that consistency.
Absolutely. It's great when you're working with data that really needs to be accurate and reliable. So what are the advantages? Well, the data validation and type safety are huge. That's the big selling point. You get that right out of the box from Pydantic. And being model agnostic, that's a big plus. You can choose the LLM that's best for your needs. And they have a seamless integration with Pydantic Logfire, which is really useful for debugging. Plus, it's very Python friendly. It just makes sense if you're a Python developer. And it makes sure that your models produce structured, predictable outputs. You can even do things like dependency injection if you want. And it supports streaming LLM output with validation as the data is coming in. So that's cool.
Streaming output with validation, that's a really nice feature. So it sounds like it can speed up development quite a bit.
Definitely. Especially for data scientists and ML engineers. And it scales well for enterprise workloads. And it fits right in with the rest of the Python ecosystem.
What about limitations? Where might it not be the best choice?
Okay, so its main focus isn't really on orchestrating those complex multi-step workflows, like some of the other frameworks we've talked about. Compared to something like LangChain or Crew AI, it's got less built-in support for managing those intricate sequences of actions. And it's still fairly new, especially for AI agents specifically. So the community is a bit smaller, fewer examples, fewer resources online, and it doesn't have memory management built in. So if your agent needs to remember things over time, you'll have to add something external for that.
Okay, so not as much out-of-the-box functionality for certain things.
Yeah. And you do need to understand Pydantic pretty well to really use it effectively. So there's a learning curve there.
Mm.
And while you can build agents with it, for really complex workflows, it might not fully replace something like a dedicated orchestration framework. And I've seen a few people online mention that there might be some issues with validation when you're using the streaming mode. And some developers might find the code gets a bit verbose because of how Pydantic uses inheritance. Just something to be aware of.
So maybe not the best for those really complex scenarios, but really good at what it does do.
Right. If you need that structured data and you want to be sure you're getting valid responses, It's a great choice.
Okay, cool. Now I think it's time to talk about LangChain agent.
All right. LangChain, yeah, that's definitely one of the big names in the AI agent world.
Absolutely. So what are LangChain agents all about?
Well, they're a core part of the whole LangChain framework.
Yeah.
And the idea is to connect LLMs to the outside world. So it's about letting those language models actually do things, not just talk about doing things. And they use the LLM to decide what actions to take and which tools to use. So it's still all about that reasoning capability.
Okay. And I know LangChain is known for having this huge ecosystem of integrations with different tools and services.
Yeah, it's massive.
So how does that benefit the agents?
It means that your agents can connect to pretty much anything. You can have them use all sorts of APIs, data sources, you name it. And you're not tied to using a specific LLM either. They have a unified interface for working with all sorts of different language models. And they have memory management built in, which is essential if you want to build an agent that can have a conversation or that needs to remember things across multiple turns. And it's great for complex tasks, things that need multiple steps or that need to use different tools in sequence. And on top of all that, they have an amazing community, lots of developers, tons of documentation, examples, and just a really active community providing support. So if you get stuck, there's a good chance someone's already solved the problem you're having.
Sounds like they've got a pretty strong foundation then.
Yeah, very solid. And LangChain is all about making it easier to develop applications with LLMs. So they have lots of features for managing and orchestrating your prompts. And people are using it for so many things. You see it across all these different industries.
Okay, so it's versatile, and it can handle a lot of different tasks. What about challenges or weaknesses? Are there things that people should watch out for with LangChain agents?
Well, it's funny because sometimes its strength is also its weakness because it's so big and it can do so much. Sometimes it can be a bit overwhelming, especially if you're new to it or if you're just trying to build a simple agent. It's not always the lightest weight framework. And some people have said that it doesn't give you as much fine-grained control over how the agent makes decisions. Some of the LLM calls are kind of hidden away under the hood. And the abstraction, while it makes it easier to get started, it can sometimes make it harder to optimize performance or to debug things when they go wrong.
Right, I can see how that would be a problem if something's not working and you can't quite figure out why.
Yeah, it can be frustrating. And the documentation, while there's a lot of it, it can be a bit scattered. Sometimes it's out of date. It's not always the easiest to navigate. And predicting how the agent's going to behave in every situation, that can be tricky. There's a risk of the agent getting stuck in loops, doing the same thing over and over and not making any progress. And sometimes debugging can feel like you're working with a black box. You don't really know what's going on inside. And like any system based on LLMs, the agent's knowledge is limited by what's in the training data. So it really relies on having those external integrations to give it access to the latest information. And there can be some inconsistencies depending on which language model you're using. So you might get different results depending on your choice of LLM. And for really complex reasoning, it depends heavily on the external tools you've connected it to. So the LLM itself isn't doing all the heavy lifting there.
Okay, so it's a powerful system, but it can be complex. And it relies heavily on integrations with other tools.
Exactly. Oh, and one more thing. I should mention that their original agent executor, that's actually being phased out. And they're replacing it with a newer framework called LangGraph.
Okay, well that brings us nicely to LangGraph then. How is LangGraph different from the traditional LangChain agents?
So LangGraph is built on top of LangChain. It's a newer framework. And it's all about building these more sophisticated, stateful applications with multiple actors. It's got this graph-based model where the different steps in your workflow, the computations, the actions, they're represented as nodes in a graph. And then the connections between them, the edges, those define how the data flows through the application. And they have this central graph state. It manages all the persistent data, things like memory, and it can even incorporate human feedback right into the workflow.
A graph-based model, that sounds very structured. So what does that allow you to do that you couldn't do before?
Well, you can create these cyclical graphs, so you can have loops, which is really useful for tasks that need a lot of iteration, where you're refining things over time, or if you need to get feedback at different stages. And it supports streaming, so you can see intermediate results and information as it becomes available, not just the final output. And they have really good built-in features for human collaboration, so you can set breakpoints, inspect the state. You can even manually edit the state of the application if you need to. And of course, it works seamlessly with all the existing LangChain tools and language models. Plus, they have Langsmith integration, which is great for monitoring, debugging, and tracing what's going on in your application.
Wow, so you can really get in there and see what's happening. And you have a lot of control over the process. What are the main advantages of LangGraph?
Control is a big one. You have a lot of control over the workflow and the state of the application. And because it can handle these complex cyclical interactions, it's really good for building production-level applications. And it's stateful. So it can remember things over long and complex interactions. And the human-in-the-loop features, those are huge for when you need a human to review things or provide input. It also lets you build these reusable modules for your workflows. We call them graphs. And it supports a bunch of different control flow patterns, so from simple sequential execution to those more complex, multi-branch, hierarchical, even cyclical flows.
So you're not limited to just a few basic patterns. You have a lot of flexibility.
Exactly. And it's more expressive than the original LangChain agents, especially for those really complicated tasks. It scales well, it's fault-tolerant. They have a visual environment called LangGraph Studio, seamless integration with LangChain, really robust memory management. And they even have this thing called time travel debugging.
Time travel debugging, what is that?
It lets you step back in time and inspect the state at different points in the execution. So you can go back and see exactly what happened, what decisions were made. It's super powerful for understanding why something might have gone wrong.
That's incredible. So it's like having a rewind button for your agent.
Pretty much.
Yeah.
So yeah, it's a powerful framework, but are there any downsides?
Yeah. What are the potential drawbacks of LangGraph?
Well, it's definitely more complex than the original LangChain agents. You need to understand graph-based programming, and you need to be comfortable managing state. So there's a steeper learning curve. If you're just doing something really simple, it's probably more complex than you need. And managing the state and the memory, it can get tricky in really big applications. And because you have to explicitly define all the paths and the logic in the graph, that can sometimes limit how much the agent can explore on its own. It's not as free to experiment.
Okay, so it's maybe not as good for those exploratory tasks where you don't know exactly what the agent's going to do?
Right. And compared to something like Crew AI, which is all about those roles and collaborations, LangGraph can be a bit more verbose when you're working with multiple agents, although in other cases, the output is less verbose.
Right.
And the fact that you have to define the initial state of the graph, that can feel a bit restrictive sometimes.
Yeah.
And you can still get those unintended loops if you're not careful with how you design your graph. And for really resource-intensive workflows, the overhead of managing the graph state, that can start to become noticeable. And reusing graphs, it's not always easy. You might have to modify them quite a bit to use them for different problems. And being a newer framework, the documentation isn't quite as mature as some of the others. And some people might find that it's just overkill if they're working on simple sequential workflows. Okay, so powerful, but maybe not for everyone. Yeah. And one last thing. In LangGraph Studio, the visual environment, if you don't explicitly define your conditional logic, it can make the graph look a bit messy. You know, with extra edges that don't really need to be there, it can be a bit visually confusing.
So that's LangGraph. Now we have one more framework to talk about. I think it's Autogen 4, and this one seems to have a different approach altogether.
Yes, Autogen 4. It's from Microsoft Research, and it's really all about asynchronous communication and an event-driven architecture, which is pretty different from what we've seen so far. So this is really meant for making collaboration between multiple agents more efficient.
Okay. So asynchronous communication, that means that the agents don't have to wait for each other to finish before they can respond, right?
Exactly. So they can kind of work in parallel. And it's more efficient, especially when you have lots of agents interacting.
I can imagine that would make a big difference for certain tasks.
Yeah, it can really speed things up. So what else does it do? Well, it's designed to scale well. And it supports multiple programming languages, mainly Python and Dolap. And it's got built-in features for observability, so you can monitor and see what your agents are doing. And they have this thing called Autogen Studio. It's a low-code or no-code option, so you can build and manage your workflows visually, which is cool. It means more people can use it. You don't necessarily have to be a programmer.
A low-code option? That's pretty innovative. I like that. So what are the big selling points, the advantages of Autogen 4?
Well, the asynchronous architecture is a big one, especially if you need that efficiency for lots of agents. It's built to scale. The multi-language support is pretty unique. You can integrate it with more systems. The observability features are great for managing complex systems. And Autogen Studio is a really nice way to get started. It's more accessible. And the fact that it's backed by Microsoft, that suggests it will probably have good enterprise support. And it's likely to integrate well with their cloud services.
So if you're working in the Microsoft world, this could be a good choice. What about downsides? Anything to watch out for?
Some people have said the documentation is a bit tricky, and if you're just doing something simple with a single agent, the whole asynchronous event-driven thing might be more complex than you need. And how well it performs at scale, that's still kind of up in the air. It will depend on the LLMs you're using. And while Autogen Studio makes it easier to get started, to really use the more advanced features, you're probably still going to need to know how to code, and you need to understand how to work with asynchronous systems.
So it might have a bit of a learning curve for some people.
Yeah, potentially. But overall, it's a really interesting approach, especially for multi-agent systems.
Okay, so that was a whirlwind tour of, what, 6 different AI agent frameworks: OpenAI Agents, SDK, Crew AI, Pydantic AI, LangChain Agents, LangGraph, and Autogen 4. We've covered a lot of ground here, so imagine some of our listeners are thinking, okay, great, but which one do I actually choose? Where do I even start?
It's the million-dollar question. And the answer is, well, it depends. It depends on what you're trying to do, what your priorities are. But we can give some general guidance based on what we've talked about today. So if you want to do rapid prototyping and you want to be really closely tied to OpenAI's ecosystem and all their latest models, then the OpenAI Agents SDK is a good option. But if you need to do multi-agent collaboration and you want to have those well-defined roles and responsibilities for each agent, then Crew AI is designed specifically for that. Now, if your main concern is data validation, and you need to be absolutely sure you're getting structured, type-safe data, then Pydantic AI is the way to go. And if you need a framework with tons of integrations, a huge community, and you want something that's really versatile, that can handle lots of different use cases, the LangChain agent is a solid choice. But if you're working with complex, stateful workflows, where you might need human feedback, and you need to have very precise control over how things execute, then LangGraph gives you that level of control and flexibility.
And finally, if you need something that scales really well and you're working with asynchronous systems, especially if you're in the Microsoft world, then Autogen 4 is worth a look.
So it really comes down to your specific project. How complex is it? What are your goals? And what are your team's skills and preferences?
Yeah, exactly. And as you get more experience in this field, you might even find yourself combining ideas from different frameworks.
Yeah.
Borrowing the best parts of each one.
Mm.
This whole field is still so new. It's changing all the time.
Mm.
And that's what makes it so exciting.
Absolutely. So that actually leads to another question I wanted to ask you. With all these frameworks popping up, do we really need them all? Are they really that different from each other? Or are they all kind of doing the same thing in slightly different ways?
That's a great question. And it's something people are definitely talking about.
Yeah.
So while all these frameworks are about building agents, they come at it from different perspectives. They have different levels of abstraction. And they're often focused on different use cases. Think of it like a toolbox. You have a hammer, a screwdriver, a wrench. They all help you build things, but they're designed for different tasks. And they each have their own strengths and weaknesses.
That's a good analogy. So there is some overlap, but each framework has its own unique purpose.
Right. There are definitely similarities, but they each bring something different to the table in terms of how easy they are to use, how flexible they are, how well they scale, and what kinds of problems they're best suited for. And we're only just beginning to explore what's possible with AI agents. So this diversity is a good thing. It means people are experimenting. They're coming up with new ways to do things. And we're seeing new trends emerge, like the move towards asynchronous architectures with frameworks like Autogen 4. So who knows what the future holds? It's going to be fascinating to see what happens next.
I agree. It's a really exciting time to be working with AI agents. Well, this has been an awesome deep dive into the world of AI agents and all these different frameworks. I feel like we've learned a lot.
I think the main takeaway is that AI agents are a powerful technology, and there are lots of different ways to build them. And each framework has its own strengths and weaknesses. And it really depends on what you're trying to achieve.
So do your research. Choose the framework that's right for you. And get building. And maybe, just maybe, you'll come up with the next big thing in AI agents.
It could happen.
And to all our listeners, thank you so much for joining us on this journey of exploration into the world of AI agents.
We hope this has given you a better understanding of all the different tools and approaches that are out there. And we'll see you next time for another deep dive into some cutting-edge tech.